All right. By knowing the degree of a polynomial function, it is possible to predict the end behavior. All right, first of all, we're going to hit this again in a minute, but the degree of a polynomial, give me some information about that. What does a degree, how do I find it? What does it tell me? Anything like that.
It's the largest exponent.
It's the largest exponent. Okay, and it tells me what?
How many x's are on?
Okay, tells me the maximum number of x-intercepts. Okay, perfect. All right, now, that power, okay, of the polynomial functions, they rise or fall without bound as the x moves towards positive or negative infinity. So all I'm saying right here is, okay, I should be able to determine the end behavior, okay, like what the tails do, based off of two things. That would be the leading coefficient, and the degree of the polynomial, that highest power. Now, the leading coefficient, a lot of times I abbreviate it LC, but today you might also see it abbreviated A sub n. Okay? And then the degree is just that highest power. Now, a couple of other things. It says the graph of f has at most n minus 1 turning points. Okay, that's where a graph changes direction, going from increasing to decreasing or decreasing to increasing. Now, n right here is your degree. So whatever your degree is, you just subtract 1. And that tells you how many times it can turn at most. And then this tells me it has at most n real 0. Now it does have n zeros. They just might be positive, or not positive. They might be real or imaginary. Okay? Okay, so let's take a look at this. We are going to look and use the graphing calculators. Hopefully there's like one that you and a neighbor can share and look on with in a minute. But for the beginning of this, I want you to help me just pick out the information from the equation. Okay, it says, I want to fill in all these blanks, okay? N is what? N is my degree. What is my degree of this polynomial? 3. All right. A sub n, that is my leading coefficient here. -1. Perfect. So I have a negative leading coefficient, and my degree is odd. Okay? My leading coefficient is negative and my degree is odd. If my degree is odd, that means that my tails are split. They're going in different directions. But if it's negative, that means that that graph is going to fall to the right. So that means on the right side of my graph it goes down. So on the left side it's going up. So as x approaches negative infinity, that's the left side of my graph. Where are my y values approaching? Positive infinity. Good job. Okay, and as x approaches positive infinity, that's the right-hand side of my graph. It's pointed down. So my y values approach negative infinity. All right, and then turning points. My degree -1, so 3 minus 1 is 2. I'm going to say 2 at most. 2 at most. All right. So if I'm going to sketch this graph, okay, this is what I want us to do. All right. If I'm sketching, I still want to use my calculator. And I'm going to go to y equals, or if you have Desmos, okay, in a little bit you can pull out Desmos. I'm going to type in negative And when you type in a negative, starting something out, make sure you use that negative that's down there by the decimal, okay? If you use the minus, it's going to give you a syntax error, okay? All right, so right here, I'm going to say negative x to the third power plus 2x squared plus x plus 1. And I want to just kind of see what happens with my graph. Okay? That's not too bad. Now, when I ask you to sketch, please do not just draw a squiggle on your graph, okay? I do want for you to actually like try and plot some of these guided points. Okay, so right here, it looks like the graph crosses over the y-axis at 1, and it looks like right near it, there's a minimum. Then the graph crosses over the x-axis again. It looks like about between 2 and 3. And it also looks like there is a maximum at about maybe a little past 1 up to 2. Okay, so I'm going to use these points to guide me with my sketch. Now again, this is a sketch, okay? We're not perfect. But there's my sketch. I plotted some points. I tried to use my graphing utility to help me with that. Okay? Now, I want to confirm right here, these maxes and minimums, those are my turning points. So I'm going to put a little check up there with that too. My turning points, I'm going to make a note right here that these are my maxes and mins on a graph. Just kind of want to know what I'm looking for. Okay. All right, now I'm going to do the same thing for the next one. What is my degree here? 4. My leading coefficient is 1. Okay, so my leading coefficient is positive, and here my degree is even. Now, if they are even, they go the same direction. And because my leading coefficient is positive, they both point up. So both of these are positive infinity. And then, let's see, I will have 3 turning points at most. All right, so I'm going back to my calculator, and I'm typing in my function. Okay. All right, now graphing this. Ooh, that one looks a little bit different. Okay. So let's see. Did not space those out evenly at all. Trying to do the best I can. Okay, so I feel like this hits between 0 and -1. Looks like it hits at the origin at 1 and between 2 and 3. Close, much closer to 3. It also looks like there's a minimum at 2, -4-ish. Okay, once again, it's a sketch. All right. Y'all okay with that? That was short, sweet, simple. Okay, here we go. Let's take a look at even and odd multiplicity. All right, if a polynomial function has a factor that is repeated, these duplicate roots are labeled as a multiplicity of their degree. So the exponents are telling me everything I need to know. Now, if a real zero, or if f of x has a real zero c, we're just calling c that point, that has an odd multiplicity, then that graph will cross the x-axis at that ordered pair, c0, whatever the number is. What is it going to do if it has an even multiplicity, though? It bounces, yeah. So I'm going to say that it touches / bounces, but that it does not cross. Okay? It doesn't actually go through it. It just kind of like butts up to it at whatever that ordered pair is. Okay? All right, so it tells me to sketch this using a calculator, but I've already got the picture there for you. All right, we've got this function f of x, and I am asked to label the zeros and describe the behavior of those roots. Now, I see my graph hit in these two locations. What are those two locations? Zero, negative 2, or how about negative 2, 0? Okay, so it hits the x-axis at negative 2. I'm going to come over here and say negative 2, 0, just to make sure I write that correctly, okay? And at 1. And that happens at the ordered pair 1, 0. Okay, now I want to describe the behavior. This right here, it crosses through, right? But it swerves and then crosses. So I'm going to say that it crosses, okay? That's fine. But I also want to state that it has a multiplicity of what? If it swerves and crosses, what is it? 3. Yep. All right, what does it do here at 1? It bounces. Okay. And this one has a multiplicity of 2. Now, if it had a multiplicity of 3, I want to remind you that that came from the exponent that was directly attached to that factor in the problem, okay? So hopefully that will be a reminder to us about the behavior, okay, or what it's going to do. All right, now it says right here, for this polynomial function, do each of these things. All right, first of all, this right here is just 0.5. That's the same thing as a 1/2 out front. This right here, it is not an intercept. This tells me that this graph has a vertical shrink. Okay? That doesn't have anything to do with a 0. But anything that has an x does. Okay? So there are 2 zeros here. What are they? Negative 2 and positive 3. What is the multiplicity of the negative 2? A 1, yep. Because there's an understood but unwritten 1 up there. And then what about this 3? Has a multiplicity of 3. Okay, now state whether it crosses or touches. All right, so at x equals negative 2, what was the behavior? Or what will be the behavior? It will cross. It will cross at negative 2, 0. And for x equals 3, what is it going to do? It's going to like linger and cross, right? It's going, I'm going to say lingers, then crosses at 3, 0. Perfect. And then what do we know about the maximum number of turning points for this? I don't see the picture, but we should be able to identify what the degree of this polynomial is. The degree here is going to be what? It's not 3. It's actually going to be 4. Because I have 1, 2, 3, 4 x's. Okay? So the maximum number of turning points is 3 turning points at most. I don't know if it's here yet. Let me check. Oh, yep, it's here. I'm going to make you a pass to go to the front office. Okay, here we go. Let's look at the very, very last set of questions. Okay, now it says to do different things. All right, it says describe the end behavior, analyze the given function by stating the domain and range, and then it wants us to tell what we can conclude about the graph based on its intercepts and turning points. Okay, so it's asking me to do a lot. Ryan, you awake? Okay. If I can't see your eyeballs, that's my definition of sleeping, so y'all make sure you're paying attention, okay? All right, here we go. Let's start out, and I am specifically going to write out what it's asked me to identify, okay? The end behavior first, and I'm going to do the limit notation. I'm going to call this function f of x. It wasn't really given a name, but I'm going to give it that name. What are my tails doing on the left and right? They're both pointing up. So both of these are approaching positive infinity. I have done the end behavior part, so I'm going to check that off. Okay. Now I'm going to do domain and range. Okay. Now, I'm looking at my graph left to right. Now, do you see right here? Do you see how like there's a little split in that? It's only because that number, -4, is right there. Okay. So I'm going to connect that. That's supposed to be a continuous graph. So my domain is -infinity to positive infinity. In my range, when I do range, I read it from, bless you, bottom to top. Now, halfway between -12 and -16 should be -14. And then halfway between -14 and 16 is -15. I'm kind of putting this in the middle of those. So I'm going to say from bottom to top, the very first y value that I have is -14.5. Now, because that is an actual point on the graph, I'm going to include that, and it goes up forever. Okay? So domain and range are complete. All right, next. Huh? Ooh, not good. Okay, just have a seat right there. Okay, let's see. Next, it says, what can you tell based on its intercepts? So I'm going to come down here and I'm going to make a little category for intercepts. Now this includes X and Y, okay? I'm going to say that the X-intercepts are estimated at X is approximately what two locations? What do you think? Does that look like it's halfway between or halfway between the halfway point? Yep, it looks like it's a quarter of the way. So I'm going to say right here, negative 2.25. What would I say for this one then? Perfect. Okay. Now, I see my graph is doing all this kind of funky curve stuff, right? I know that a straight up parabola or quadratic, which is x squared, looks like a U-shaped graph. So this is definitely not a U-shape, right? Okay, it's got a little bit more going on. So also, I'm kind of looking here, and I see 1, 2, 3 turning points. If I see 3 turning points, that means that my degree has to be at least what? 4. Yeah. So I'm going to say right here that these two have a multiplicity of 1. So I'm going to say that there are 2 real roots. That's where they cross over the x-axis. And then they have 2 imaginary / complex roots. Complex numbers, imaginary numbers, same thing. Okay? Keaton, I need you to have this. Okay, now we have already said that this is a 4th degree polynomial. Okay, it's a 4th degree polynomial. So that means, and that has a special name of a quartic. Okay, I'm going to make a note right here that there are 3 turning points. And I'm going to draw an arrow to that 4th degree just because those are connected. What would I say about my y-intercept here? That's going to happen at y is approximately what? If I look at my graph, what are these counting by though?
1.
They're counting by 4s. So to me, this looks like it's like 3/4 of the way down. So then that would make it what? Not 3, but -3. Okay, so I've written down x-intercepts, turning point information. I've answered everything it's asked me to. Okay, when you get a multi-step question like that, I highly recommend that you're kind of going through checking off that stuff. All right?